In this section, we're going to take our knowledge of sine functions and cosine functions, and we're going to apply some translations to those functions. So we're just going to build on some skills that you already know with some information that you've already learned. So our question is, how can you model periodic behavior? Our objectives are to graph translations of trigonometric functions on a coordinate grid, and then write equations of translations of trigonometric functions. So for vocabulary, each horizontal translation of certain periodic functions is called a phase shift. So if you're moving horizontally, it just has a special name called a phase shift. So here we have horizontal translations, those are our h value, and vertical translations are our k value, and just like we did before, when it's inside the parentheses, it's the opposite value. So if it says like -2, we're actually going to move right 2, so opposite direction. Whereas with k, when it says -2, we move down 2. So inside the parentheses moves left and right, outside at the end moves up and down. Hopefully that sounds very familiar to you because we've done it so many times. Alright, what's the value of h in each translation, and describe each phase shift? So our first one is g of x equals f of x minus 2. Now since the 2 is inside the parentheses, this is a phase shift. We're moving horizontally left and right. So since it's a -2, we're actually going to be moving to the right 2. So h is 2 and our phase shift is 2 units to the right. For this one, y equals cosine of x plus 4. Since it's inside the parentheses, that means we have a phase shift left and right. Since it's plus 4, we actually move in the negative direction. So we move left 4. Alright, graphing translations. Here we have the graph of y equals sine x. And we're going to graph the translation. If we were to graph y equals sine of x plus 3, all that we would do is, since this value is on the end, this plus 3, we just take every value and move it up 3 on our graph. So here, and this one is 1, 2, here, and here. This one is off the graph, and this one is here. And we just make a smooth curve to connect all those points. So plus 3 just moves the whole graph up 3 units. What if we did this one, the sine of x minus pi over 2? So this one, we're going to do a horizontal shift. We're going to use move pi over 2 units. And since it's minus pi over 2, we're going to move to the right pi over 2. So hopefully you remember where pi over 2 is. So if this is 0 right here, get my pen, here we go. This is 0 right here. This is pi, and pi over 2 is going to be halfway between the two. So this is pi over 2. So everything needs to move over to the right 2 units. So we're going to take and just move every value right 2. 1, 2. 1, 2, that's off. This one moves 1, 2 here, 2 here. And the reason we're moving 2 units is because of our value of the value of our x coordinates. There we go. Lovely. So just moving units of, well, this one would actually be going back up here. Don't keep going down. Okay, so that's moving to the right pi over 2 units. So for families of sine and cosine functions, we talked about the parent function. For sine, that's y equals sine of x. If you do any transformations, a is your amplitude, b is your period, or b helps you determine your period, and then you have h moves left and right, k moves up and down. The same applies for cosine. It's all the same thing. So a is your amplitude, 2 pi over b is your period, where b is your cycles. H is your phase shift left and right, and K is your vertical shift up and down. So all the same information for both of them, you just have to remember, don't slide down sine. Sine goes up first when it's positive. Okay, graphing the translation of y equals sine of 2x. What's the graph of y equals sine of 2 times x minus pi over 3 minus 3 halves in the interval 0 to 2 pi? Okay, so we get a problem like this. In order to be able to graph our translation, first we have to know what our parent function graph looks like. So if, in this case, our parent function is y equals sine of 2x. So we're going to go ahead and, we need to graph that. Sorry if you got a sneak peek of that. But first let's look at our values. A is 1 because there's no number in front of the sign. B is 2. H is our value, pi over 3, and K is our value of negative 3 halves. So we're going to sketch the cycle sketch one cycle of y equals sine of 2x by plotting the 5 points, the maximum, the minimum, and the x-intercepts. And then we're going to use h and k to translate that function. Alright, so let's go ahead and get started. So if we have, okay. So here is 0. And if we look at y equals sine of 2x, what it says is we complete A is 1. Since B is 2, that means we complete 2 cycles from 0 to 2 pi. So that means one cycle, they want us to graph one cycle. One cycle is from 0 to half that distance, 0 to pi. So I'm going to put pi right here. And then we're going to have a halfway point in between, pi over 2. And then we're going to have halfway points in between that. So I have pi over 4 and 3 pi over 4. And then what's going to happen is, since it's a sine function, it starts here. Our amplitude is 1. So we're going to go up 1 and down 1. Okay, here, 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 and here. So this is our y equals sine of 2x. Now, to do the translations, we have to go pi over 3 units to the right. Well, let me pick a different color. How about green? Pi over 3 units to the right. So if we're going to do pi over 3 units to the right, that means we're going to have to go, so pi over 3 is about halfway between pi over 4 and pi over 2. So I'm going to have to move each one of these over about 1.5 units. Okay, so we have the right transition. Now we need to go our up and down. So we're going to go down 3 halves. So that's 1.5. So I'm going to extend this. There's negative 2, and then negative 3 is going to be off the graph. But then we have to go down 1.5 from each value. So 1.5. So there's my new point, down, down 1.5. There's a new point, down 1.5. Down 1.5, down 1.5. So these are my new values. So, there. So this is a translation. So make sure you sign your parent function and then do your left and right and up and down translations from there in order to do these. They're a little more complicated, but totally doable. Okay, for writing translations, what's an equation that models each translation? Y equals sine x, and we're going to go pi units down. So in order to go down, is that inside the parentheses with our value of x, or is that outside? Well, up and down is outside, and since we're going down, it's going to be in a negative direction. Oops, I didn't write that one down. So that means the formula for this one with the translation is y equals sine of x minus pi. I'm not sure, but Math Excel might have you put the x in parentheses just to signify that you know for sure that the pi is on the outside. For the second one, y equals negative cosine of x, and we're going to move 2 units to the left. So since we're moving left and right in this case, that means your value is going to be inside the parentheses with the x. So it'd be y equals negative cosine of x. And since we're moving left, that's a negative direction, we're going to do opposite sign plus 2. That would be your formula for that one. Alright, here's your lesson check. I would like you to do these 2 problems with your partner first thing. Go over these 2 questions. You're going to describe the shift, and then I'm going to have you make a function with these specifications of sine. And your homework is lesson 13-7, and I hope you have a great night.